Good evening everyone, we are here with Diego McAllister, who has cracked the code on time travel, so to speak. Hello Diego.
Hello Jane.
I understand that you have proposed a technically sound method to time travel.
Yes, I have.
And this evening will be the first time that you reveal the details of this revolutionary idea.
That is correct, Jane.
Now, will we be able to travel forwards and backwards in time?
Good question, Jane. And at this point, we have worked out the details for traveling backwards in time. But we currently don't have any proposals for traveling forwards.
Interesting.
But some members of our crew have proposed that once we are adept at traveling backwards in time that we'll eliminate the need to travel forwards because the fruits of traveling into the past will more than prepare us for our future.
I see. And you know Diego, what fascinates us more than anything else is that you got your start in an inner-city community in one of America's most troubled cities. And so, we are anxiously awaiting your proposed idea. Especially after the success of your first two proposed ideas which were revolutionary in their own rights.
Thank you, Jane, and I'd like to continue by sharing that our proposed method of time travel only involves sending our minds back in time.
Only our minds?
That's right. We discovered that it is possible to sit still in the present frame of reference and at the same time, send our thoughts back in time.
Really?
Yes, and it just so happens that this method has been around for almost 5,000 years. And that time period is just about as far back in time as we are able to go.
That's quite a ways back in time.
Interestingly enough, the closer we come to 5,000 years in the past, the more we find ourselves restricted to the geographic area of ancient Mesopotamia or Sumeria.
That's an interesting coincidence.
And as we move forwards in time, from starting point of 5,000 years ago, the broader the geographic domain becomes. Thus, we are able to visit just about any spot on the face of the planet as we approach the present.
Remarkable, but you mentioned that this method of time travel isn't new and it's been around for almost 5,000 years.
Yes, Jane, that is correct. And the travel method is aided by artifacts such as clay tablets to bound leaflets. And when we attempt to travel back 5,000 years, we find ourselves dependent on one or two special clay tablets, and the closer we come to the present, aids become more numerous and complex. And these time-traveling aids allow us the chance to know the outlook and thoughts of men and women from throughout history.
Going back up to 5,000 years, right?
Right.
Now Diego, these time-traveling aids wouldn't happen to be recorded writings such as books and such.
Yes, Jane, you're right. Books are a key example of time-traveling aids and how to send your thoughts back in time. Which of course, give us the chance to know the minds of people that lived long before us.
Books for time travel. Diego, you're not serious.
Jane. No, I am not. But, I do think that this was a great way to emphasize the importance of all forms of recorded history. But, it's also meant to help us to understand what it would mean to have a library of media based on the recorded thoughts of people from our future, which I will explain later.
So, would you like to share your real proposal for time travel?
Sure.
Thanks Diego.
Well Jane, in relativistic physics, mass exists in three states: tardons, luxons and tachyons. Tardons represent mass that is greater than zero, luxon mass equal to zero, and tachyons, which are theoretical, mass less than zero. Plus, tardons travel at speeds less than the speed of light, luxon at the speed of light, and tachyons above the speed of light. And according to Einstein's equation, mass greater than zero requires an infinite amount of energy to approach the speed of light. Thus, it is impossible to accelerate tardonic mass to the speed of light. And it just so happens that our bodies are comprised of tardonic mass. Thus, our bodies require an infinite amount of energy to accelerate to the speed of light. And the reason this is important is because according to Lorentz equation, that when the velocity of mass equals or exceeds the speed of light, then time within the moving frame of reference stands still or reverses, respectively, with respect to the original frame of reference. But again, tardonic mass is confined to speeds to less than the speed of light, so the only change in time that may occur when two frames of reference comprised of tardon move at different speed is a retardation in the rate of passage for the frame moving faster than the other. But, slowing time is not our goal. Our goal is to stop its progression or reverse its direction. And evolution is to convert tardonic mass to tachyonic. and this process was conceived from the normal event of tardonic mass being converted to luxonic mass in fissionary nuclear reactions. So, we just taken it one step further. We have a proposal to convert tardions to tachyons, thus making it possible to travel faster than the speed of light, thereby making it possible to go back in time.
Diego, could you break down what you've just said?
Sure, Jane. Well, to paint a better picture, if we built a spaceship that could travel at half the speed of light and then left the Earth on board the spaceship and returned 10 years later while traveling at a constant speed of half the speed of light, we would discover that everyone had aged 10 years while we only aged some fraction of that amount.
I follow.
Great, Jane. And to continue, if we were to leave Earth on that same spaceship at the speed of light and then return 10 years later, then we would find that everyone had aged 10 years and that we hadn't aged at all. And that is because when a frame of reference achieves the speed of light, time stops with respect to the inchio frame. But the problem is that it would require an infinite amount of energy to achieve the speed of light. Thus, it is impossible for this to take place unless the mass on the moving frame of reference is equal to zero, such as the mass of a luxon. And luxons do exist. Some examples are photons and neutrinos. But we are not photons nor neutrinos, so it is impossible for us still. But we can convert tardions to luxons. This is recklessly achieved in nuclear fissionary reactions where some of the mass of, let's say, a uranium isotope is converted to light, which are photon particles. Well, we took it one step further. We are able to convert tardion mass into tachyon mass, and in a controlled fashion. Thus, we are able to put a person in a spaceship, then convert it to tachyon mass, which naturally travels faster than the speed of light, with the expectation of it returning to the Earth prior to time that it initially left. And we have a proposed means to reconvert the tachyon mass back to tardion mass, thus completing the journey. Likewise, we are able to convert luxon mass to tachyon mass. Thus, we are currently able to send light back time. And currently what this amounts to is us being able to send messages to the past. So, all future breakthroughs are reported to the past to accelerate development process of a time-travel device.
That's an interesting concept. And if I understand you correctly, then the benefit of all future discoveries would compound immediately in the now, thus placing us further ahead at the point in time from where the initial breakthrough was made, with each applied use of future breakthroughs in the now time.
Exactly. Thus decreasing the length of time it takes to go from theoretical time travel to real.
Thank you, Diego.
You are welcome, Jane.